All right, this is our second piecewise function question here, number 11. Again, it didn't format super well, and I actually just changed some of it. This should be like that. So we're going to go with, for the purposes of this video and on your study guide, f of x equal to x plus 1 between -3 and 2, but then there's a less than or equal to sign at the 2, and then absolute value of x when x is greater than 2. So let's go and look at this the same way we did with the previous one. What is the transition point between these two? Between this one and that one? Well, it's at 2. And then we should also look at this other transition point here at -3. So I'm going to go ahead and put a tick there. And that is the space. These are the x values right here, where we're going to graph this first function right here, x plus 1. So x plus 1 is, it has a slope of 1, and it has a y-intercept of 1. So I'm going to go to that slope of 1, and I'm going to put a dot. That's where the to the y-intercept of 1, and put a dot. And then we're going to go up 1, over 1, up 1, over 1, up 1, over 1, and then back 1, down 1, back 1, down 1, until we get to these edges. So I'm going to go like this. I'm actually going to go beyond with the dotted line so you can see where it gets cut off. So there, that's what it would look like, and it would keep going in both directions if it was just y equals x plus 1. But this one only follows y equals x plus 1 between -3 and 2, not including that -3. So we're going to put an open circle there, but yes, including the 2. So we're going to go out to x equals 2 right here, and then up there, and put a solid closed dot. Now what I'm going to do is connect these like that. That right there is this portion of the graph. And I will erase this little piece so that it's not confusing anymore. It's just that green line, and it goes from this space to that space. Next, we're going to go and graph the absolute value of x. I'm going to go ahead and say, all right, we go here and we go that way. But I'm going to graph the absolute value of x using dotted lines all the way through like that. It would keep going in both directions there. Hopefully you can see the dotted line going up and to the left and up and to the right. But notice I only take the absolute value, my purple graph here, when x is greater than 2. So come up to here, put an open circle because it's greater than, not greater than or equal to, and then follow the arrow out like that for forever. So that's our graph. And just like the previous one, I will fill over in red so you can see what the entirety of the graph should be. It should be this to here, open, and up, and arrow. So that's what your graph should look like. Hopefully you're okay with that. And now we can go on and answer the question. All right, domain here. So notice domain, remember it's x's. I'm going to do this one in purple. So domain is x's. So notice the smallest x we have here is -3, and then it goes up and it includes them. It includes this. Maybe I should, well, it starts at -3. I'm going to draw it down here so it doesn't cross over that graph. I could do it on the x-axis, but the lowest x value for which this thing exists is -3, and then it goes up, includes it at 2, and then it pops into this one. So it just keeps going, right? This thing is defined for all x's that are greater than that -3. So I can write that in two ways. I can write parentheses, -3, comma, infinity, or you can write whichever one you prefer. I can write -3 less than x less than infinity. Both are totally fine. Make sure you have a parenthesis to be representative of this open circle, and or just a less than, not a less than or equal to. For the range, we'll do this in green. I'm gonna come off the graph over to here to show so I don't intersect with any of this stuff. But what is the lowest y value for which this function exists? Do you see that that would again be at this spot right here? It doesn't exist down here anywhere. The red graph only exists starting right there. So that is -2 on the y's, and I'm leaving it open because it doesn't actually include that -2. And then it goes up again. And again, we get this like overlap thing where, yep, I have a y value, I have a y value, I have a y value. And then for this chunk between 2 and 3, I could take either one of them. It's fine. And then I have a y value, y value. So this keeps going up to infinity. So again, we need to write the lowest value first. So -2, and then infinity like that. Or if we were to do it using the inequality notation, let's say -2 less than y less than infinity. Either one is good. Lastly, we're going to find some intercepts. So let's go to blue. Here we go. The x-intercept is where this thing hits the x-axis. Remember, this is the x, this is the y. So what x value is that? It is x equals -1. The y-intercept is where this thing hits the y-axis. So that is this spot right here. What y value is that right there? It's y equals 1. You can always write this as -1, 0 or 0, 1, indicating x equals -1 and y equals 0. Or you can do it like this. Either one is good for me. So again, I hope you're starting to feel some confidence with these piecewise functions. I hope the coloring helps. Yeah.